JSON has been the standard of communication and data transfer in many platforms, just like what we had in the previous recipe, where all our data were stored as JSON-like documents using MongoDB Data Store. Let us now start this section by expounding JSON binding and JSON processing features of Jakarta EE. Since this is now a new section, we will be setting up a new Maven project with a blank CDI bin descriptor file. This project will be utilizing a resource local JPA data layer that still uses our product table. For the meantime, this Maven project must have the following underlying dependencies that will support our recipes. First is our Eclipse JSON framework that will provide us all the implementation classes for the JSON binding, and the Glassfish default provider of Java API for JSON processing. Also, we will be utilizing the same DAO class implementation to derive our service class. Let us now implement our product JSON service that will contain all the components of these recipes. Let us start with Jakarta EE's JSON-B feature, which is a standard binding layer that uses JAX-B specification in converting Java object to and from JSON formatted data. There are two interfaces involved in JSON-B. First, we have the JSON-B interface that contains from JSON and to JSON methods capable of objects serialization and deserialization respectively. Next, we have the JSON Builder interface, which is capable of creating multiple JSON-B instances and also allowing us access to some JSON-B operations and properties. I have here a getJSON product service method, which shows how JSON-B is created and how it performs marshalling to a single queried product object. Also, another method here shows how a queried list of products is converted into a JSON message. Let us now test these two methods using JUnit framework, but first we need to verify if we are running the resource local type of a JPA layer there with this open JPA runtime property set. And since we will be loading our JPA using standard JUnit executions, we need to explicitly generate our entity manager factory by explicitly invoking or running this init method inside our product JSON service. Let us now go to our test source folder, create the necessary package, and set up our test class for our product JSON service, create our setup and tear down methods with our setup initializing our product JSON service class. First, let us execute our getJSON product to generate a JSON message for a product ID 10. So there you are. Now let us verify if our getJSON prods will generate an array of JSON records. So there you go, the result. On the other way around, JSONB can deserialize or parse a JSON formatted file using any input stream or file reader APIs. To extract a single object, it requires the entity's object type to properly map all the JSON value types to their corresponding POJO properties. But when it comes to extracting a list of objects, it requires a runtime list type. In this recipe, I have prepared two formatted or JSON formatted files. One is the product.json file, which contains a solo JSON object, and a products.json file, which contains an array of JSON objects. All these files are located inside the resources class path folder under the directory JSON. Let us now test our two methods here. First is our get from JSON file. Running this test will give us the name of the JSON object, which is smiling loaf. And this method here, which will give us all the records from our JSON format message. And lastly, JSONB can save any Java objects in a JSON text file using any output stream or file writer API classes. Just like in this service method here, which retrieves all the products from the product table and save them in a certain JSON file. Let us now test this method and check if we have the file generated in our JSON folder. So here I am storing all the product objects inside this prod list JSON under the JSON directory. Execute this test method. Let's check our JSON folder here. And there you go. All the records stored in this prod list through JSONB. When it comes to the entities involved, we can add other properties using some JSON mapping annotations. For instance, if we want to change the default order of the JSON value properties, we can decorate the entity class with JSONB property order and assign it the desired order of property. Also, if we want to change the property name the time this object is serialized, we can do that by using the JSONB property. These next discussions will be on JSON-P, or the JSON processing features of Jakarta EE. Definitely, there will be no marshalling or unmarshalling processes involved, but JSON-P can only not generate a JSON message from any Java object, but it also can transform and manipulate an existing JSON structure. JSON-P has a factory class called JSON, which contains all the JSON processing operations. It has also two immutable JSON structure objects, namely JSON object and JSON array. JSON object is similar to a map collection with entry records in it, and JSON array is a list of these JSON objects stored in a list collection. I have here a new service method which extracts a JSON object from a single queried product object, and a new method, another method, which creates or builds JSON array from a queried list of products. Be keen on how many JSON-P objects you create, since all of these objects are immutable. Just like in this getJSONProduct service method here, an empty JSON array object is created first, and then the JSON structure is built separately using the JSON array builder class. Afterwards, we let this empty JSON array object points to the newly built structure. Not only that, JSON-P can also provide us a delete operation through the remove method of the JSON array builder class. It eliminates a particular JSON object located at a certain row. Not only add and remove, JSON-P is capable of updating some parts of an existing JSON array through the set method of the JSON array builder. Let us now run some tests on these JSON-P methods, starting with our build JSON product, which will generate a JSON object from our product ID 10. There you go, JSON message from our product ID 10. Then let us test our get JSON products, which will generate a lengthy array of JSON objects. There you are, our JSON array data. Now, this first JSON object will be deleted by running the next JSON-P operation, which is build and remove JSON products. So here you go. It's deleted, or it will be replaced by the following new product by running the build and update JSON products method. So from product 10, it's now ID 6789, product name Ginger Tab, at price 6789.35.